Edith. I'm Edith Thatcher, and I am the co-lead, along with Lisa Howard, of the Sacramento-Roseville chapter of Citizens Climate Lobby. Citizens Climate Lobby is a nonprofit, nonpartisan, grassroots advocacy organization, and we are focused on national policies to address climate change. As an organization, we work to persuade Congress to pass legislation that significantly cuts greenhouse gas emissions. Tonight is part 2 of our Earth Day Climate Change Speaker Series. And this is our April 27th, 2022 presentation, and it's entitled, "What Will It Take to Tackle Climate Change?" In this speaker series, we are talking about different aspects of climate change, what it will take to tackle the challenges, and why we should have hope. I'll put some information about the series into the chat with a registration link for May 4th. And our talk on May 4th is entitled Hope in the Face of Climate Change. And the speaker for that will be Lisa Howard. She's sitting there with all of the beautiful poppies behind her. I am delighted to introduce this evening's speaker, Kathy Dodson. Kathy is a climate ambassador with Climate Interactive. She's also a member of the CCL Sacramento-Roseville chapter, and secret fact, she is an avid bicyclist. She will speak for about 45 minutes, and then we'll take questions. And I'm trying to consolidate the questions to the end because of the recording. But feel free to put questions or comments in the chat, and we'll track those and try to address them. So thank you very much for joining us. And Kathy, take it away.
Thank you, Edith. Can everybody hear me? Okay. I'm so excited to share the next hour with you all. And we'll be talking about various climate policy actions that we can take and actually see which actions can be stronger and more effective than others. I am a physical therapist with a master's in public health. I am not a climate scientist, but when I first saw this model a few years ago that I'm going to share with you in a few minutes, I was so excited because it helped me compare all sorts of climate policies at one time, and again, see which ones were more effective than others. So I went on the En-ROADS Climate Interactive site. I took their training sessions to become a climate ambassador, which I am now, and I've given dozens of these talks, and each time I do it, I learn something new. I grew up in the Bay Area, and my family used the Sierra Nevada as our playground. We didn't go to fancy hotels or take fancy vacations. We went week-long hikes, backpacking trips on the John Muir Trail. We camped, we hiked, and we skied. And some of my most memorable experiences are the snow camping trips my dad would take us on. We would put backpacks on our back. We were really quite young at the time, hike into some deserted lake and the snow. And all day long, it would be fun. It would be nice and warm, and we'd play and throw snowballs and run around in the snow. But when night came, in order to save weight, my dad didn't pack any air mattresses. And when night came, he just cut down some pine branches and fir branches and put that on the snow and put our sleeping bags on the snow on those fir branches. And needless to say, none of us kids got very much sleep, staring up at the stars at night, freezing to death, just praying for the night to end and the sun to come up again. So I really appreciate my dad taking us up into the mountains a lot, and some vacations were easier than others. I still hike in the Sierra, and I'm kind of devastated by the changes I've seen. The forests are drier now. The bark beetle is destroying the pine trees, killing the pine trees. And wherever a wildfire has gone through, which is pretty common to see now, the hills are barren, leaving just matchstick black tree trunks standing. So I've not only seen the changes, but I've also experienced climate change from the 50s and 60s up to now. That's spurred me to want to do any kind of action to address climate change. And one of the actions I'm taking is giving these presentations. I want to leave the Sierra Nevada for the future generations so they can spot wildlife like the bears that I would see in the forest and enjoy the peace, serenity, and the adventure that being in the mountains and the forest can bring. So let's get started. I'm going to share the first En-ROADS screen. Okay. You may have to move the pictures of all of us kind of around to see all of the screens. Sometimes you can't see all of the information on the graphs. So this is an En-ROADS climate workshop that you're attending, and this is what I've learned how to give and to explain to people. What is En-ROADS? It's a climate model that was developed by a group called Climate Interactive, along with MIT Sloan Sustainability Initiative. It uses the latest research on climate science and solutions. It's interactive. I'll be asking you all for input on what policies you want to see changed. And so we can see what the effects of those would be. And you can put those in the chat. I'll ask for that in a little bit later. It's also transparent. There's apparently over 400 pages of equations and assumptions that they made to build this model, which took years to build. And it's also been tested against other climate models and compares very favorably to them. We're going to take a quick look at the science of climate change, kind of the history, and see what's in store for us. We see on this graph, it talks about atmospheric carbon dioxide. Over here, carbon dioxide concentration in parts per million, starting at 160, going up to 480. And we see a timeline at the bottom, going from 800,000 years ago up to the present time. We see that carbon dioxide concentration in the atmosphere has always varied, some hundreds of years more than others, but it's always been variable, and it's always stayed below 300 parts per million. But since 1950, we're not following the same usual trajectory. Our carbon dioxide in the atmosphere is just exponentially increasing, and now we're above 400 parts per million of carbon dioxide in the atmosphere. Let's take a look at global temperature change since pre-industrial times. They've defined pre-industrial times as 0 here, 0 degrees, and we're looking at the changes from the average of pre-industrial times. That would be about from 1850 up to kind of the present time. The two different colors are two different data sets, and you can see that they track pretty favorably. They're kind of the same, even though they're from two different sources. So from 1850 to around 1930, we see variations in global temperature, but it's kind of hovering around 0 still. 1930, there's kind of a rise in global temperature, and then the temperature hovers higher up to about 1970. And from 1970 on, the global temperature is consistently increasing, and we're about 1.1 degrees Celsius above pre-industrial times. Where do carbon dioxide emissions come from? We'll take a look just at this section at 2018, and these are the emissions in gigatons of carbon dioxide per year. Most of our carbon dioxide in the atmosphere comes from burning coal. A lot comes from burning oil. Still a lot comes from burning natural gas. This other section is making cement and natural gas flaring. And finally, we have this brown section, land use change, which means cutting down trees or burning forests to change land into grazing land for animals and for agriculture. If you're like me, I wasn't really sure. I didn't really know what a greenhouse gas was or what they were. So this chart helps me remember that. And these are the major greenhouse gases, and they're in carbon dioxide equivalents in gigatons. Okay, most of the greenhouse gases in the atmosphere, 68% or so, come from burning carbon dioxide, from burning fossil fuels and emitting carbon dioxide. 7% of the greenhouse gases comes from carbon dioxide emitted when we cut down trees, burn down forests to use the land for grazing for animals and agriculture. 18% of the greenhouse gases comes from methane, which comes from grazing animals, particularly cattle, also from waste disposal sites, and a lot of methane leaks from natural gas pipeline systems. 5% comes from the nitrous oxide that we make to make fertilizer, and 2% comes from man-made gases, the F gases that we use in our air conditioners and cooling systems. So these are the major greenhouse gas emissions. Let's take a look at what happens to our atmosphere and the carbon dioxide equivalents in the atmosphere. We'll use the bathtub model. There is always a removal of carbon dioxide naturally from our atmosphere, and that's symbolized by this drain that is always open. Water is always flowing out of the bathtub, and as far as carbon dioxide in the atmosphere, plant material takes up carbon dioxide, and the oceans take up a lot of carbon dioxide. The problem with our level of carbon dioxide in the atmosphere or water in the bathtub is that our emissions are so much greater than the natural removals of carbon dioxide. So we are emitting so much more carbon dioxide into the atmosphere, and just like water will rise in the bathtub and overflow because the faucet is turned on full blast, so the amount of carbon dioxide keeps rising in the atmosphere. Here is a graph from the En-ROADS model that you'll see in just a minute. Along here, we see degrees Celsius, and along the bottom, we see a timeline for our century, the year 2000 to 2100. We're right here at 2022. We see that if we continue business as usual, burning fossil fuels, but also using solar and wind energy like we are expected to reach 3.6 degrees centigrade above pre-industrial times. Our climate goals set by the Paris Climate Agreement are symbolized by these two red lines. The first goal is to keep the rise in temperature by the end of the century to 1.5 degrees, and that will prevent the worst climate scenarios that we can expect. If we can't stick to the 1.5 degrees maximum, let's let the temperature increase to 2 degrees, but there will still be dire consequences if the temperature reaches 2 degrees by the end of the century. Unfortunately, continuing business as usual, we're expected to reach 3.6 degrees Celsius above pre-industrial temperatures. So it shows us we have to do a lot of things to reach either of these goals by the end of the century. Let's take a look at what happens if there's 4 degrees Celsius of warming by the end of the century. Sea levels are expected to rise 4 feet. More than 2/3 of the glaciers in the Himalayan mountains will have melted. They'll be gone. 1 in 6 species is expected to go extinct, and 3/4 of the world's population is expected to be exposed to lethal heat for more than 20 days a year. If we can limit the warming to 2 degrees, are we out of the woods? Is that fine? No, not really. We see that river flooding is expected to more than double than it is now. About 90% of coral reefs will become bleached, thus leading to their death. Droughts will be expected to last on average 4 months longer. And in California, it seems like we are in a perpetual drought. And finally, over 50%, over half the world's population is expected to be exposed to lethal heat for more than 20 days a year. So let's stop sharing this, and I'm going to share the En-ROADS Climate Simulator. And now we get to look at solutions. Can everybody see this graph? Okay. So it might look a little confusing, but it's really not that difficult. You might have to move around the screens of all of us so you can see all of the graphs. Put that up there. Okay. We see that, again, temperature is expected to rise 3.6 degrees Celsius above pre-industrial average temperatures throughout the century. We have the year 2000 up to 2100. And instead of graphing temperature, this business as usual line, it's looking at greenhouse gas net emissions. And we see that our greenhouse gases that we expect to emit, business as usual, continue to increase. Let's take a look at this chart. It charts the global sources of primary energy. And down here in the colors, you can see what we're talking about. Coal is represented by brown, oil red, gas blue, renewables green, and so on. So let's take a look at our sources of energy that we plan to use from the year 2000 to 2100. And this is business as usual. The use of oil, the red line, is expected to increase to about 2060 and then level off. The use of coal, the brown line, is expected to continually increase until the end of the century. Coal is relatively cheap to mine and to transport. And remember, this is not a United States model because we are using less and less coal, but it is a global model. So the use of coal is expected to continually increase. The blue line stands for natural gas. And just like coal, we're expected to use more and more natural gas until the end of the century. Green line stands for renewables. That's wind and solar energy, as well as a little bit geothermal and hydropower energy. And we can see that right about now, 2022, the use of renewables is expected to very dramatically increase. And by the end of the century, provide about as much power as coal, natural gas, and oil. Pink stands for bioenergy, that's burning plant material to get power. Blue is nuclear energy. And orange here, called New Zero, stands for some kind of magical, fantastic, zero carbon energy supply, such as nuclear fusion or thorium fission. It hasn't really been developed yet, and it will take a long time to develop, experiment on, and build up to scale. So they've left that at zero expectations. There's finally a category down here called carbon price, and that's putting a price on the companies that emit carbon into the atmosphere. Okay, we are trying in this model, again, to get this temperature to maneuver all these levers and get a temperature of 2 degrees and hopefully even 1.5 degrees by the end of the century. So how do we do that? I'll show you as an example with coal. What if we highly tax coal? Now take a look at all of these energy supplies here, and coal is the brown line. And if we instituted a tax on coal today, what would happen to our use of coal and to the use of other energy sources? We're highly, highly, highly taxing coal. And I'll do that again so everyone can see. Go back to our starting point, watch the brown line and kind of the green line. And what we see is that when we put a tax on coal, our use of coal drops pretty dramatically because nobody wants to pay a lot of money to extract coal from the ground. And the use of other energy supplies went up minimally, and the use of renewables did go up also. Now let's take a look over here. Our greenhouse gas net emissions, did they decrease? Yes, they did. The black line is business as usual if we continue doing exactly what we're doing now. The blue line represents putting a price on or a tax on coal. And we can see that we've lowered the greenhouse gas net emissions by the end of the century. And we've lowered the expected temperature rise from 3.6 degrees Celsius down to 3.4. So that's a 0.2 degree difference and improvement in the temperature by the end of the century. All of these 18 categories have this lever. And I'm going to explain the rest of the categories to you really quickly. This is a transportation category. We can look at energy efficiency, making cars more efficient, driving more miles per gallon, using hybrid cars, making sidewalks wider and more pleasant to use so people walk more, making bicycle lanes safer to use, and also really improving public transportation so one person doesn't need to get into one car to go to one place, and all of our energy is more efficient. We can also drive electric cars, trucks, and buses. We can electrify our transport. So start thinking about these policy changes, and you can start writing in the chat which one you'd like me to move the lever on to see how much it changes the temperature by the end of the century and how much greenhouse gas net emissions are reduced. There's also a section called Building and Industry, and we can also make our buildings more energy efficient. That means insulating our houses, using energy efficient appliances, energy efficient heating and cooling systems. It also means that industry can be made more efficient. We can also electrify our homes and our industries and use electricity to power and heat and cool them, and for the machinery in the industry. Population, we can assume that population grows faster or slower than what is expected in this model. Same thing with economic growth. Might it grow faster or slower? The last category is, or one of the last, is land and industry. Deforestation, the cutting down and burning of forests to provide land for grazing of animals and agriculture. What if we could stop that or highly eliminate that? Would that make any difference in the final temperature at the end of the century? Same thing with methane and other gases. We could decrease the amount of cattle grazing on the land because they produce a lot of methane. We could move to a more plant-based diet. Also, methane is leaked from natural gas pipeline systems. So we could capture those leaks, shut them off, and decrease the amount of methane. Also use less nitrous oxide in our fertilizers because it includes the other gases, not just methane. There are some carbon removal techniques. There's natural technique, sort of by planting trees and having trees and plant life take up the extra carbon dioxide, remove it from the atmosphere. And there are some technological systems being developed now. They're not scaled up, they're not super useful yet, but there is room for improvement throughout the century of using technological methods to remove carbon from the atmosphere. So that is the end of me explaining the graph. I hope that some of you have put questions in for Edith, like what you would like me to show. This is as interactive as we could make it because it's kind of a large group of people.
Hey, Ethan, I'll have to talk to you later. Bye. So Kathy, we've had several people asking about afforestation. Could you start with that?
Okay, we'll start with afforestation. I'll move the lever here. And this assumes that we are able to plant around the globe trees in land that's more than twice the size of the country of India. So think of the size of India in your head, double that size, and then add a little bit more. And that's the amount of area that they think we could plant with trees throughout this century. Look at the temperature, 3.6 degrees, business as usual, and think in your head how planting all of those trees would affect the temperature at the end of the century. A lot, might take a degree off. It might completely solve the climate change, get us down to 2 degrees. It might do nothing. You don't need to look at sources of primary energy over here because we're not looking at sources of energy. We're just looking at removing carbon from the atmosphere. So let's plant trees twice the size of the country of India and watch what happens to the emissions of greenhouse gases and the temperature of the planet. So even with planting all that area of trees, we have only decreased the temperature by 0.1 degrees Celsius, not very much. It's helpful. We're a little bit less greenhouse gas net emissions, but not a big change. This is a section where I like to show you all. I hope you all will look at this graph on your own. You can bring it up by going to climateinteractive.org. And when you're on the graphs, you can click these 3 buttons and it brings up the assumptions that they used to create this certain graph. And you can change the assumptions. You can say that planting trees doesn't start in 2022, it starts in 2025. You can make a few changes, whatever you want in the assumptions. And then also, let me move my screen. You can hit this information button, this I, and it brings up a lot more information on each section. And what I like to look for, especially on the afforestation section, there are potential co-benefits of increasing afforestation, because it's kind of sad that it only decreases the temperature 0.1 degrees Celsius, but there's a lot of co-benefits anyway. New forests can create new ecosystems and protect existing wildlife habitats, biodiversity, and ecosystem services. Larger and healthier trees and more in cities can reduce the urban heat island effect and reduce the amount of energy we need to cool and heat our homes. And there's a lot of jobs created in tree planting, care, and maintenance. So for every one of these 18 levers, again, you can hit the 3 buttons and then hit the I and get a lot more information about each section if you want. Okay, so we've done afforestation. We're down to 3.5 degrees. We'd like to continue to reach our goal of at least 2 degrees. What else, Edith?
So Jay put in electrification, and then we also had electrification of transportation.
Okay, so I guess the first one would be building an industry electrification. So we're going to use electricity to power the machinery in industry and heat and cool industrial factories. Once again, let's look at the sources of primary energy this time and see if we're using less or more of certain kinds of energy as we electrify our buildings and industry. We'll look at those sources first. And we see that if we push policies to use electricity instead of fossil fuels for power for our buildings and industry, watch the lines of energy again and see what they do. So Jay, that is just a huge, wonderful change. It spurs us to use a lot more renewable energy, and our use of coal and natural gas decrease. And we see that we've dropped the temperature another 0.3 degrees. So that's a pretty effective measure to take to address climate change. Now, what if we all drive Priuses, electric cars, and also trains, trucks, and buses can be electrified? It's hard to electrify global ship transportation and airplanes because batteries are so heavy that they're not effective yet to electrify those forms of transportation. Again, look at the sources of energy. What'll happen to the renewables, the coal, and especially the gas, the petroleum. Okay, I'll do that again. It takes a while to look at all these different colors and lines moving. So watch what happens to the renewables, the green line, and then the petroleum, especially the red line. So we see that it really cut our use of oil and spurred the increased use of renewables for sources of energy. And we've decreased the temperature. Ooh, were we at 3.2 before? I can't remember. 3.2. And that has only decreased the temperature by 0.1 degrees Celsius again. It has changed our energy mix, but unfortunately, it doesn't change the temperature that much. Any other ideas, Edith?
Let's see, what about, there was a question about nuclear. So what if we look at the increase of nuclear use and the decrease of nuclear use?
Okay, if we build more power plants, let's take a look. We will expect the light blue line to increase nuclear energy. And I really don't know what the other lines are gonna do, the use of other energies. So let's subsidize nuclear energy. So we're using more nuclear energy. Okay, and it looks, I'll do that again. But we can see that nuclear energy goes up because we're subsidizing it. and the renewables and natural gas and coal use goes down. And if we highly subsidize nuclear energy, we've shaved another 0.2 degrees Celsius off our final temperature. So that's a pretty significant change. And then I think the person wanted to see what if we stop using nuclear power plants. So we're at 3.1 degrees Celsius now, and our sources, energy sources look like that. So let's see if we retire all those nuclear plants. Again, I think it just, if I look at these sources of energy, it looks like they all kind of go up. And probably nuclear power goes down a little bit. Which makes sense because we're substituting the nuclear power that we're using from other energy sources. And our temperature has changed from 3.1 degrees Celsius up to 3.2 degrees Celsius. So it warms the planet by retiring nuclear plants now. I'm going to put in as if we were subsidizing nuclear power plants. That was one of our power strategies. So we're at 2.9 degrees Celsius above pre-industrial times. Any other ideas? People putting in any other suggestions they want to see?
Would you look at methane? We've had a couple of different things that I think fundamentally come down to reducing methane.
Okay, so what if we all globally, hopefully, adopt more plant-based diet, eating less beef, less cattle, which release a lot of methane? And what if we can cap all those natural gas leaks that are coming out of the natural gas pipelines and leaking that people don't know about now? Also, maybe use a little less of the F gases in the air conditioners and less nitrous oxide to make fertilizer. So we won't see any change. You don't need to look here because we're not changing the source of energy. We're just hopefully reducing the emissions. So as we highly reduce methane and other gases released, we see a pretty dramatic decrease in greenhouse gas net emissions. And we went from, was it 2.9? Yeah, 2.9 degrees Celsius. And it moved us really far down to 2.5. So that's a 0.4 degree change, which is really significant. So that's a significant area to concentrate on if you want to address climate change. But we're still at 2.5, not at 2 or 1.5. Anything else people are wondering about?
We had one other which said, what about renewables? And that's going to be interesting with the scenario that you've got up there right now.
It sure is. So we already are encouraging renewables by electrifying our transportation and industry. So take a look at the energy sources. We're going to incentivize using renewables. We'll just look there for the first part of this and see what happens. Okay, off the charts. I'll do that again. Let's see what happens to the other sources of energy. Okay, and I think you all can see that they all decrease and the use of renewables increases. And when we do that, we decrease the temperature by 0.2 degrees. So as you can see now, that's not an insignificant amount. It's not the best, but it's not an insignificant amount of changing the global temperature. And we're using less or emitting less greenhouse gases. Any other questions? Or it's still
so we have two more.
Okay.
One is, what about deforestation?
Okay, let's disincentivize. Let's try and stop people from cutting down forests, burning forests to make land for grazing and for agriculture. We don't need to look at energy supplies because we're not changing the supply of energy. We're only trying to actually suck up some of the emissions and take them out of the atmosphere by preventing the deforestation. Okay, a 0.1 degree. So we see the greenhouse gases are here. And it reduces greenhouse gas emissions a little bit and a 0.1 degree Celsius. So it has some effect. Any other, one more
And
question?
we had one
To get
more
to?
question, which was, what about a carbon tax?
Okay, if we put a tax on carbon, that means, gotta move this, taxing the mining companies, oil and gas drilling companies when they take the fossil fuels out of the ground. So take a look at the sources of primary energy. And in the scenario we've built, and every time I do this, we build a different scenario, a different order of things. We can see that already our use of coal, oil and natural gas is pretty low, and use of renewables is pretty high. But let's see if we put a price on those fossil fuels. Oh, my goodness. Okay, makes an even more dramatic change. Renewables goes up even more. The use of the fossil fuels decreases, and we have decreased the greenhouse gas net emissions almost to zero. And let me see. Oh, and we've decreased the price, the temperature to 1.7 degrees above pre-industrial times. So we reached our goal. As you can see, putting a price on carbon is a pretty strong effect. I declare this game over. We've reached 1.7 degrees. Congratulations to all your suggestions. Thank you, everyone. I'm going to return the model to baseline and show you a few of the actions we can take and their own specific individual action or influence on the climate change. Because once we've got a lot of actions piled up on one another, sometimes the effects are a little different for the policies that we're changing kind of at the end of our list of actions. So let's quickly look at some of these. What if we reduce methane and other gases? What will the temperature get to? 3.1 degrees. So that's a 0.5 degree difference. And as you kind of now realize, that's a pretty huge difference. What if we plant billions and billions of trees? Only a 0.1 degree difference. Not as strong as methane. Removing other gases. How about carbon removal using direct air capture techniques like that? And we can see 3.6 to 3.2, that's a 0.4 degree difference. That's pretty significant. Driving electric cars, trucks, and buses all by itself. What'll that do? Will that be huge? No, only a 0.1 degree difference. What if we make buildings and industry more efficient? Let's see what we get to. 3.2. So that's a 0.4 degree difference. So retrofitting our buildings with more insulation, changing to energy efficient appliances, double pane windows, that can really help limit the warming of the planet. And what if we put a price on carbon all by itself? And we can see that if we put a price on carbon, we've decreased the temperature from 3.6 degrees all the way down to 2.6 degrees. So a full 1 degree Celsius difference. And if you would test all of these, you would see that that is the strongest effect of any of these policies, is putting a price on carbon. Now, I want to tell you that that's what Citizens Climate Lobby really advocates for, but this model was built by Climate Interactive, a totally different group of scientists and people, but they also show through their science-based model that putting a price on carbon is the strongest thing that we can do. I'm going to stop sharing this screen quickly and go back to this screen. Just a sec. Okay, so maybe people can put in the chat. This is really a brief introduction to this whole model, but I hope you caught a few things or learned a few things, and maybe hopefully you can put in the chat things that surprised you or things that you learned that you can take away and apply to the real world. So I'll give you a few seconds to write into the chat things that were surprising. I know it sure surprised me when I saw it. And maybe Edith can, as soon as you put them in the chat, Edith can read some of the answers off.
Was there anything that you thought was going to have a strong effect, and in fact, when Kathy showed you the model, it didn't? Or something that you thought was, you know, pretty minimal and we don't really need to think about it very much, and in fact, there was a strong impact? There has been a lot of very good discussion in the chat, Kathy, which I look forward to sharing with you when we save the chat.
Okay.
Kathy, you want to go ahead and talk about what
Yeah.
some of your original first thoughts when you went through this
Sure.
for the first time?
Well, I know what surprised me. I thought driving electric vehicles would solve the problem of climate change. I don't know why, probably because I live in California and we're working towards that. And I was surprised at the minimal change that actually had. I also didn't know that putting or decreasing methane and other gas emissions would be such a strong effect. Those gases don't stay in the atmosphere as long as carbon dioxide, but they're really powerful gases. So in the first couple of decades that they're in the air, they create a very powerful greenhouse effect. So working on methane was surprising to me. I would like to work more in that area. And what do I take away from this is trying to give more of these presentations to let more people know about the power of various actions and policies and see which are the most effective.
So we did have a few comments in the chat that came through. Barb said it looks like making moderate changes in all areas will bring down the projected temperatures. Jim said, I was surprised that the carbon tax alone only reduced the temperature so that it's still warm. It's still 1.7, which is unacceptable. Susan says, we have a Sierra Club in British Columbia, which is hosting an interaction with nature and art. Oh, sorry, expression workshop. Thank you. And let's see. Lori says, you often hear about planting trees as a solution. I would not have thought planting trees equivalent to the entire surface of India would have had such a tiny impact.
Yeah, I agree. And as far as the first comment that we need to do moderate changes to all of these policies, that's one of the takeaways from this exercise is there's no silver bullet. And even the second comment too, putting a price on carbon won't solve it. Not one action will solve this issue. There's no silver bullet. There's only silver buckshot. We need to address all of these areas of addressing climate change to make a big difference. So those are about the big takeaways.
All right, so now lots of stuff has come in. Do we have time to go through some more?
Yeah.
All right. One of them is a question. Why do you think afforestation has a lesser effect than removing carbon using technology? So in other words, carbon removal from the air,
yeah,
and so on. Do you have any thoughts?
That's a really good question. Yeah, I've thought about that a lot because I'm so surprised by that. And I think when you think of planting trees in the area twice the size of the country of India, if you think about it, you've got to first buy all that land. Well, how many years is it going to take to purchase all that land? And then you've got to grow millions, billions of tree seedlings. How long will it take to plant them and have them grow? And then you've got to take them out to all that area and plant them. How many years will it take to plant land twice the size of the country of India? Probably a lot of years to plant that. And then it takes decades for the trees to grow to a size that can actually pull a significant amount of carbon out of the atmosphere. So I like to think of the afforestation as it doesn't make much of a difference in the temperature by the end of this century, But I would hope that if this graph continued on to the next century, that there would be a big difference because the trees would already have been planted, they would have grown, and they would be large, and they would be taking more carbon dioxide out of the atmosphere. That's my hope. And the technology, even though it's not functional yet, a lot of people are working on it, and there's actually a lot of investment in that side of carbon removal. So I guess this model assumes that it could reach the level that it does in this model of taking out carbon dioxide from the atmosphere. But I'm very kind of saddened by the lack of improvement in the temperature by the end of this century with afforestation.
So here's another, this is actually a question. If transportation is 40% of greenhouse gases, and I think that's in the US, why does the model show such a small impact, I'm assuming from the electrification of cars?
Yeah, especially if you live in California, that seems impossible because we kind of use our cars to get everywhere. But when you think about the whole world, not everybody has a car. A lot of people don't drive cars. Everything isn't California or the United States. So even apparently electrifying the vehicles doesn't make that big a change. And I'm assuming that's because not everyone in the world has a car and is using electric vehicles.
Okay, I'm going to just try and hit a few comments, and then I'll come back to the questions. One comment was carbon tax moves all the needles. Let's see. There's a comment that California's forests are now carbon positive because of all the forest fires. Afforestation and deforestation do help, however, with biodiversity. Let's see. And Susan, who is from Canada, observes that in Canada, the carbon tax is a huge political issue.
Yeah.
Okay, so now I'll try and come back and pull out a few of the questions here. Can you discuss the level of uncertainty in the model for the various strategies?
No, I can't. But I do know that this model, if you go on the Climate Interactive website, they'll go into much more detail, and they compare this model to about 5 or 6 different models. And some, I guess, take weeks to make one calculation. This model I've heard makes like 35,000 calculations a second or something to change all these levels of fossil fuel, all the levels of the graph changing that you saw. And all I know is that this climate model, even though it's quicker and easier to use, it tracks the same as the other climate models that are more, I don't know about more expensive, but more detailed and take longer to model something. So it's similar to a lot of other climate models.
A question for you, Kathy. The model was just updated, was it not, in December? Were they?
With COVID, I can't remember if it was updated in this last December, probably just in, I don't remember if it was December 21 or 2020, but the model used to predict that the temperature would rise 4.1 degrees by the end of the century. And because renewables are becoming much cheaper and more in use, when they upgraded this model, we didn't have to expect that the temperature would reach 4.1 degrees Celsius. They've now downgraded at 0.5 degrees Celsius to 3.6 degrees Celsius because the use of renewables was so surprising. So that was the major change that they made in one of the Decembers. I can't remember.
Okay, and someone made an interesting request, if I can find it, and which would require you to go back into the model. Okay. Let's see. What if you All right. If anybody can actually see it, would you read it? Let's see. I think it was if you did put a price on carbon, and
Okay.
then you did sort of modestly the energy efficiency, electrification, buildings and industry. What does that look like?
So those three actions, putting a price on carbon, building an industry, energy efficiency improvement, and electrification, gets the temperature down to 2.4 degrees centigrade. So that's the 1.2 degrees Celsius change, which is great. Still not to the 2 or 1.5.
And then if you added energy efficiency.
Of transportation?
Yes. Or
okay.
electrification of transportation, because there have been
Okay.
so many questions about that.
Yeah. So that drops it another 0.2 degrees. No, 0.1, just 0.1 degree. Down to 2.3.
Okay, and then, I'm sorry, I kind of confused it. Kathy, then will you go back and just show with only, so we had, before you were building up a model, and just show what does electrification of transportation do on its own?
Okay. We electrify our trucks, buses, trains, and cars, a 0.1 degree Celsius difference. And again, we can't electrify airplanes except for small airplanes that go, I think, less than 2 hours distance. And we can't electrify yet big cargo ships going across the oceans. The batteries are too heavy. So it's just the cars, trucks, buses, and trains, and it makes only a 0.1 degrees Celsius difference.
Okay, and Jim, I'm going to take your questions backwards. What is the effect of population?
Surprisingly, not that much. If we assume, well, I can go both directions. If the population grows higher than is expected, a 0.2 degree increase in the temperature by the end of the century, and if the population grows less than expected, just a 0.1 degree difference. Improvement, I should say.
And then Jim's other question is, what if you just pushed all the levers?
You know, I don't know. I can't remember that. I don't know that I've ever done that. Okay, let's do it. Let's see what.
But doesn't the order make a difference?
I don't think so. If we do all of them, I don't think it would. I mean, I'll do them all. I don't think I've ever done this.
All right, and folks, if you have, we're coming down to our last few minutes. If you've got other questions or scenarios that you'd like to see, put them in the chat, and we will address those before we let you go for the evening.
Bioenergy, I think it would be that direction. Bioenergy actually would go that way. Okay, I got to move this. What do we get down to?
Lisa comments.
Economic growth. Wait, economic growth is low. Sorry.
Yeah, put economic growth and population the other direction. I think you've got them both high.
Trying to move low growth.
Yeah.
Low growth.
Oh, look what a huge difference that makes.
I can't. Is that one? Yeah. Yeah. Increase.
All right, Jim.
Okay.
There you go. We're all going to have to be awfully good to get to there. Kathy,
yeah.
Got any? We've got about 4 minutes left.
Okay, I'd like to share just 2 more slides about citizens climate lobby. So let me stop sharing this and share once again here. So if you found this presentation effective, and I hope you have, you've seen that we do have the tools to do this. We can do this. Solar and wind energy are getting so much more cheaper, excuse me, and we're using them a lot more. Corporations are becoming interested in addressing global warming. So are countries and states, and the general public, like you, is also becoming more educated and more engaged. So Citizens Climate Lobby, as Edith said before, it's a nonprofit, nonpartisan grassroots organization, and we are really focusing on putting a price on carbon. And as you saw by the Climate Interactive Group's climate model, that's the strongest thing we can do to address climate change. So if you want, I would ask you to go to the Citizens Climate Lobby website and here and hit the Take Action button. And if you click on that, it brings up this page, Write to Congress. And in about 1 or 2 minutes maximum, you can write to your 2 senators and your congressional representative. You put in your street address and your zip code, and then they know where you live and who your senators are and your representative. There is a form letter that's already written there, like, please address climate change. You can customize the message, write in what you want to write, hit send, and those 3 people will get the message from you. And my deep belief is that the coal mining agents are companies and oil and natural gas extraction companies have lots of big lobbies in DC, lobbying for their industries. And the only people to debate them or to write to the lobbyist is general citizens, us, and say that we care about climate change and we care that they take action. And please include putting a price on carbon also. But I feel if you can pass this message along, everybody write to their representatives, everybody that lives in the United States. Let's try and be as strong as the coal and oil industries in reaching our representatives. So that's the end of my presentation. Again, you can go to climateinteractive.org. And this is Drew, one of the man that gives all the presentations and the training sessions. Also on there, you can find how to become a climate ambassador, how to take training to teach these seminars. And I hope this has been helpful to you all. Thanks for coming.
Thank you, Kathy. I know that you've spent many hours learning to use this climate simulator, and it's a pretty complicated tool. And I know you've given numerous presentations. The tool, of course, is not perfect. As Kathy said, it's a global tool. It's looking at the world, and when she, pulls those levers across, it's extreme. So the comment that was made about, we're going to have to do a lot of things moderately. There's no silver bullet. Those are very important points. I did want to say Kathy really enjoys doing these presentations. And if you are in a school or a class and you would like her to give you another one, you can put your name and an email in the chat, or go to the link that we provided in the Eventbrite and let us know, and we'll ask her if she's got time in her schedule. Please remember that a lot of other people are telling our congressional leaders what they want them to do, and we have to speak up too. Particularly for those of us in the United States who are voting this year. We have our primaries on June 7th and the elections in November. For every candidate, know where they stand on climate change and how they think it's going to affect their area. And this is true for the school board, county sheriff, board of supervisors, city council. It's really important. Anyway, thank you all for participating. I look forward to sharing the chat with Kathy. She's going to be fascinated by the dialogue. So thank you for your good questions, and good night.
Thank you.
Thank you, Kathy and Edith. Thank you so much.
Thank you, Lori. And anyone else?
Do you want me to play the other video on the way out as people are going?
Yeah.
Okay.
Yeah.
energy efficient or clean up their act with cleaner energy. What is a carbon fee and dividend? And how does it help solve climate change? Burning fossil fuels causes carbon pollution, which traps heat and warms our planet to dangerous levels. To stabilize our climate, we need to stop carbon pollution. How? By changing the rules to the game. Right now, carbon pollution is free for everyone. With a carbon fee and dividend, fossil fuel companies pay a fee when they pollute the air. Since most companies like saving money, they'll change their behavior to avoid the carbon fee. They will become more energy efficient or clean up their act with cleaner energy. With this policy, our carbon pollution goes down while green goods and services go mainstream. Costs for some things will go up, but for many purchases, we'll be able to substitute a greener choice. And as businesses move to greener products, they'll provide us with more affordable green options. For example, car companies will shift to producing affordable electric cars. And power companies will replace fossil fuels with clean energy. And remember that carbon fee? The money collected from fossil fuel companies goes to every American as a monthly dividend or carbon cashback. People can spend the monthly cashback however they want to, helping everyone afford the transition to green energy. When we stop burning fossil fuels, our air will be clean, our health will improve, and our climate will stabilize. All we need is a price on carbon, with the money given back to the people. Learn how you can support putting a price on carbon at cclusa.org.
Thanks, Lisa.
See, Susan from Canada, are you still on the phone? Let's see if I unmute you, maybe you can talk.
Myself. Well,
Okay.
I'm unmuted myself now.
Oh,
I'm
wonderful.
in,
Susan, where do you live?
in Okanagan in British Columbia. It's close between Kelowna and Vernon.
And was that one of the first parts of Canada where they put the carbon price into effect?
It was, and they've had a huge debate between the Liberal Party and the Conservative Party of Canada over carbon tax, and the Alberta government, which is our oil and gas province, which is very conservative, has been fighting all. We've got a split in our country between Saskatchewan, which has heavy oil, and Alberta, which is very oil based, and they have the oil sands. And then we have BC, who's accepted the carbon tax. We've got Ontario, we've got the Keystone XL, we've got the Trans-Canada pipeline, that we've got so many issues with oil pipelines. It's unbelievable here.
Turn
But we
off
might
the
have
recording.
James Cameron doing a movie on it, the one that did the Titanic.
Right.
That movie director, he went up to the oil sands in Alberta and tried to do a documentary too, but he stopped it too. So, but I'm glad you're hosting this program.
Well, I was just curious a little bit what some of the reaction was, what some of the political response has been in Canada now
Well,
that
with
you're living with it.
Obama, see, I'm a Democrat supporter too, and a Joe Biden supporter. And what happened with, say, with Keystone XL, what happened when down east they were going to make a pipeline, and that got stopped, and then Alberta got upset, because they wanted to export the oil somewhere, and then they